This is the third video on section 7.2, Fubini's theorem. And so here we're going to look at theorem 202. So remember in calculus 1, the integral was a way of finding the area under the curve. But remember, now if we have a function of two variables, our graph is a surface. So if we have this region, so this is a region that's a subset of R2, and there's a closed bounded region in R2, and f is a function from that closed bounded region into the reals, and the function value is greater than or equal to 0 for all x and y and r. So what we have is we have this graph above the xy plane. And so we have this three-dimensional, so we have this object that's three-dimensional, and it has a volume. And so we integrate over that closed bounded region of our function, and that is the volume. Just like in Calc 1, integrating the curve would give us the area under the curve. But here, because we have a function of two variables, our graph is three-dimensional. And so we can talk about the volume of the region under a surface. And so that volume is just going to be the integral. So example 203, we have 3x squared plus y squared plus z equal to 25. And we're asked to find the volume of the region bounded by this, the planes x equal 2, y equal 3, and the coordinate planes. That's the way it's worded in the notes. Well, the coordinate planes are x equals 0, y equals 0, and z equals 0. So we're just finding the volume of the region that's above the xy plane and below this surface. So the first thing we do is we write z as a function of x and y, and we're going to integrate over our region of z, of our function, dA. According to Fubini's theorem, we can, this is a rectangle, so we just have 0, 2 cross 0, 3. We can integrate in either order. I chose x, so we're going to integrate 0 to 2, and then with respect to x. So remember, when we do that, we're just going to pretend y is a constant. So we integrate with respect to x. We have 25x minus x cubed minus xy squared. We'll substitute 2, we substitute 0, and we'll subtract. And we simplify that. And now we have the integral from 0 to 3 of a function of y. This is now just a calculus 1 problem. So we find the antiderivative here, which is going to be negative 3 halves y plus 42y. Our limits of integration are 0 to 3. So we find the antiderivative. We did that up here. Substitute 3, substitute 0, subtract, and the volume is 108.